Hi there, so thank you for joining us today. And before we start, I'd like to extend my appreciation to all those who made today possible. Asri Malaysia, as well as Mr. Hafiz and Ms. Hidayah from steadworks. The topic we will be covering is GIS and BIM for transportation, which includes some use cases for railways, highways, and etc. We are very blessed to be in the IR 4.0, the Industrial Revolution phase, which emphasizes on the importance and benefits of digital transformation of our working processes. And this impacts the transportation industry like any other industries. And if you are joining us here today, you might as well be acquainted with the terms GIS and BIM. And if these two terms are foreign to you, allow me to define it. GIS stands for Geographical Information Systems, which is a technology Esri has been using to enhance location intelligence through data collection, interoperability, analysis, and visualization. BIM, on the other hand, is a relatively new technology that has received great industry acceptance recently due to its highly practical nature in consolidating and organizing detailed construction drawings in the building information modeling process. Now let's have a think about some of the key market drivers that have been funneling focus into the GIS and BIM alliance, which includes increasing project efficiency with bridges that connects systems for a full construction cycle, right, to help meet project timelines and reduce uncertainties during transition between project stages, and also to decrease risk by increasing operational health and safety and environmental awareness. One of the other drivers is to increase the ability to analyze and visualize environmental impact assessments and encroachments into protection zones of forest reserves and natural elements, or existing structures like bridges or culverts. And then there's the drive to maximize investments to digitally enable the people to use data and technology and simulate the adoption of available technological advances to improve our nation's skill sets and perspective. Stakeholders can also have a better understanding of their project, and the expectations can be visualized throughout the process of the different stages, allowing them to make more informed decisions. And lastly, the more crucial part, which is simplifying communications between teams that make up of planners, engineers, geologists, modelers, operators, the general public, and more. Now, the innovations that drive the advancements of GIS technology continue to grow every day. And these innovations are used by people like you to increase efficiency, to promote sustainability, and to simplify communications, and so forth. Now, in the complex world that we live in today, we are including more and more technology into our lives to help us do things we couldn't imagine a while ago, such as GeoAI and machine learning, capabilities to detect objects in real time, using big data to transform the way we analyze, visualize, and communicate with large volumes of data. And last but not least, enterprise integrations, where building information modeling is redefining how architecture, engineering, and construction, or AEC, projects are stored and processed. We are excited to be aligning with our national directives and advancements in line with the national Fourth Industrial Revolution policies, as well as embracing the construction revolution with the Construction Strategic Plan 4.0, which emerged to guide the local industry players with specific initiatives and goals, thus driving the digital transformation of the AEC scene locally. Now, Esri has established partnerships with a great number of companies that enable us to leverage on the most current technologies. So allow us to introduce to you our partnership between Esri and Autodesk, which has been established in 2017 between our president, Mr. Dangerman, and Autodesk CEO, Mr. Anagnost. Now, Autodesk is the leading software product manufacturer for AEC-related industries, and their software includes the like of Revit, BIM 360, Civil 3D, just to name a few. And this will improve the way our customers work and reduce inefficiencies. And this changes everything. Now, the ArcGIS technology, when partnered with Autodesk BIM technology, will serve to combine the best of breed between geographical sciences and engineering design. The tagline below comes with the vision to be able to make anything, anywhere. While Esri has the capacity to and capabilities for planning, city-facing context views and the associated data at the regional scales, Autodesk has the power to detail the contents that shows up inside the models, the buildings, roads, structures, the parameters, etc. This enables both organizations to grow strength to achieve a more matured integration between GIS and BIM, to remove silos between teams, to create more connected workflows, and most of all, to reduce risk, inefficiencies, data loss, and cycle times. Now, I would like to touch on the theoretical part of how GIS and BIM can function and can be applied to the real world throughout the life cycle of a transportation construction project. This is where the limitations of the applicability of the technology is being pushed every day and improved. Now, GIS and BIM is able to incorporate the requirements for both the capital portfolio management wheel on the left-hand side, which involves master planning, regulations enforcement, providing services, and so forth, and the project delivery wheel, which involves the preliminary design, construction, and documentation parts of the project lifecycle on the right-hand side. Crucial information is kept in the loop and is cycled between systems that are fundamentally different, but they are able to communicate with one another and share information seamlessly. All in all, generating a digital twin on top of the built environment for all levels of project personnel to use with confidence. Now, digital twin is, as I'm sure you have come across, a popular term these days. And to understand that, we first look at the distinctions between GIS and BIM. Now, the geographical information system essentially covers capabilities that are in a regional scale, such as city models, parcels, planning, utilities, indoors, and imagery. Now, geometry features are stored abundantly within geodatabases, with the ability to query and apply analytics to these attributes through georelational tables, which are slowly but surely moving to cloud environments. Now, on the other hand, computer-aided designs has the role of graphics display for engineers, and although geoprocessing add-ons were built, the core differences between these two technologies remained. Building information modeling, or BIM, involves building models, detailed designs, costs, materials, and schedules, which are incumbent processes within the realm of construction management. And by merging these two technologies together to create a digital twin, we are essentially forging a single source of truth for any project, so that all levels of a construction project, especially with great lateral spans like highways and railways, can work off systems that can talk to one another, eliminating silos of data and allowing seamless collaboration. Within Esri, we work with geographical infrastructures, but what is it essentially? Geospatial infrastructure is a system of systems that interconnects people, processes, data, and technology. It can serve as the core that talks to other systems while also processing data within its infrastructure. So GIS applications are transforming infrastructure workflows, right? And also supporting specialized design and engineering processes. But most importantly, it encompasses the components that we apply to make sense of the people who are contributing to the project database, streamlining the process in planning, helping coordinate detailed designs, allowing contractors to build based on accurate and authoritative information, migrating into operation, and finally, using all the information cycled through the entire process to facilitate with the maintenance of the transportation project. Now, with the numerous drivers and challenges that come with it, the GIS and BIM process essentially creates a unified environment where in traditional construction processes we may have limitations in the project handover process, or serving outdated data between teams and harvesting information from a non-authoritative system of records. And now with the GIS and BIM alliances, seamless collaboration can be achieved, right, to help all levels have a deeper understanding of the roles and deliverables, and most importantly also to make better and informed decisions. Now, between the interactions of the GIS and BIM system, we are constantly keeping in mind ease of use of each element to build confidence in the user's abilities that they may also take pride in their work. And between ArcGIS and Autodesk, web services of layers and models, files such as construction documents and drawings are synced and are designed to meet open standards to ensure interoperability. Some of the applications available are ArcGIS Pro, which helps with data visualization, geoprocessing, and interoperability for CAD files, computer-aided design, drawing files, where building models and their attributes can be directly imported from Revit or Civil 3D. ArcGIS Dashboard serves similarly to a command center where information from numerous channels are collected, organized in the back end, and served in a single page. So you can monitor, for instance, the progress of the construction, HSE-related incidents, project finances, and cost claims from contractors, operational or maintenance statuses of routes, and so forth. Scene Viewer is a platform where any authenticated person from the team can access detailed drawings of as-built designs, you query or update information right from the site. And this can also be customized to fit into other web pages and applications. Now, on the right-hand side in Autodesk Construction Cloud Platform, data from InfraWorks, Revit, and Civil 3D can be imported into the ArcGIS environment through Autodesk BIM Collaborate, Autodesk Docs, and bring it all together with ArcGIS GeoBIM, which I will cover briefly near the end. Now, in this part of the presentation, I would like to draw your focus to some of the solutions that have been implemented around the globe using ArcGIS technology, some of which leverages the strengths of other partners in our network. And this is particularly true for the roads and highway sector of the transportation industry. I ask that you keep an open mind, and please feel free to ask any questions along the way and drop us a question in the Q&A panel. Now, in the process of planning for a highway, for example, or a light rail transit, we often meet some of these wants or needs from the clients, which some of you may be able to relate to, right? Following from the two wheels of the project life cycle I've illustrated previously. So, for example, I have a client who would like to plan buildings and model traffic impacts Now, how do I actually achieve that? Do I use BIM models? Do I use traffic analysis? Do I use historical data? Perhaps I would also like to visualize assets along the highway alignment. Are we going to collect it manually using pen and paper? Or are we using digital forms to enable capture of these assets along the highway? Or perhaps I would like to generate spatial queries and analysis around an urban area. Is it done through GIS? And these are the questions that we ask and we get asked about all the time. So in the field of transportation, users are not only interconnecting and building the fabric of interconnections, they are looking at powerful things like accident analysis, being able to detect problems and then fix them. Some are working on highway operations, looking at dashboards of what's going on in real time, and look at the railroads and lightning strikes. And goes on into modeling as illustrated in the use of AI and machine learning for object recognition in Bavaria, in Germany. Now, this is also a global custom example of how GIS ArcGIS is being used to transform the way road and highway do work, such as using smart maps to better plan, manage, and maintain infrastructures, using BIM visualization and digital twin to facilitate modeling, construction management in the form of the dashboard, 3D data integration, field reporting with quick capture, and also dashboard with CCTV footage and embedded, as well as real-time data such as the highway crash analysis in the state. This is also an illustration of the examples that were featured in the recent S3 user conference for the transportation industry, where Department of Transportation's used real-time traffic monitoring, stored the data for analyzing trip purposes, and there have been solutions also for optimizing bus routes and stops and analyzing in real time bus ridership and modeling origins and destinations. Other uses include mapping road crash data and traffic collisions, truck parking optimization, and other use cases within the transport industry outside of the highway realm include drone delivery optimization, airport space management, and even managing maritime shipping in port environments. Now that we have established the abilities of the ArcGIS environment, let's move on into demonstrations. And we will be showcasing some of the solutions that we have handpicked from global and local use cases that we have found to be highly applicable to our local environment. Start with this. So this is a custom-built application with JavaScript by a German developer for a road over bridge and the underlying railway track. This showcases the power of merging GIS and BIM technologies in one platform, where on the left-hand side you have GIS, and on the right-hand side you have building information modeling. These work seamlessly together, where the user can query and review information on both sides. Especially true where in GIS details may not appear. You have that also interconnected with BIM, where specific parameters of the engineering materials will be detailed out and to be shared with contractors and workers on the ground alike. Both have information synced to one another using the cloud environment, and it can be used by independent checking consultants, engineering consultants, and they are able to review both from expanded perspective and also in detail. Now, suppliers of materials can also know exactly which grade is required from the attributes of the materials, as well as their dimensions. Next, I would like to show off a proud local use case incorporating CAD designs as well as GIS. And this was adopted by MRT for the MRT 2 SSP line, Sungai Buloh, Sedang, and Putrajaya. So first of all, this is their portal to GIS and BIM, where all the information is stored and accessed, showing the Chan Sao Lin cut and cover for underground station with a BIM overlay, and a high resolution imagery overlay for the track alignment, as well as a historical imagery for automosaics, which are aerial photos that have been corrected. On top of that, there's also a 3D model time-lapse for construction progress monitoring, which can be done. This is shown within the scene viewer itself. And a BIM review of time-lapse for underground stations, approximately just 50 meters from the existing tracks and roads. As you can see, the BIM model is stationary, and the cut and cover is being changed through time. On top of that, this is a Dubai prototype, which is built by Esri Professional Services. This really showcases how GIS and BIM come together to showcase both detail and also the regional scale in which this entire development is planned upon. I would like to bring your attention first to the bookmarks, where you can seamlessly, straight away, be able to see different views that you would like to highlight to your stakeholders or your engineers. And on top of that, you can also have details of each and every object around the environment. For example, let's go into details of one of the buildings. By selecting this glass pane, I will be able to draw out all the information as well as the document path. Attributes are accompanied and they are synced between AutoCAD BIM and the scene viewer in ArcGIS Online or Enterprise. On top of that, I'll just expand my view and showcase how you can use different levels so first, I would like to try at level 81, which will provide me with a slice of the entire building at level 81. Allowing me to detail out all the parts that are required for inspection, as well as their accompanying attributes. The best part of this collaboration is that throughout the construction lifecycle, I'm able to monitor and discern the effects the building will have on the surrounding environment to ensure that my development is sustainable and serves its purpose. Thank you. And now I would like to invite Mr. Hafiz and Ms. Hidayah from Steadworks to share their experience of working with building information modeling, as well as shed some light on the realities they face while working with Autodesk Revit and ArcGIS Pro. And over to you, Mr. Hafiz.
Okay, hi everybody. So thank you, Caleb. All right. So for the 3D BIM models, so we present and showing the demo. So as what the Caleb mentioned previously, the Autodesk Construction Cloud connects a lot of information to the ArcGIS platform. So this information can be collected in the 3D BIM model as it goes through the various phases of a project, from plan to design to build, and finally for the operation and the maintenance. So a lot of data is generated, and in BIM process, the 3D BIM model can become the single source of truth for all stakeholders in the project. Okay, the reason why the 3D BIM model as a single source of truth, because that every stakeholders in the involved with the project, we access to the same file of the BIM model. So everyone from the project owner, from the project team, from the design, from the architects, CNS, M&A, they will access and using the same BIM model that will be shared in the platform. Okay, so basically the project owner normally we start with the plan or the conceptual stage, so which will be involving with the LOD 100 to the 200. So from there they can, what we call it, get the idea, the information, the initial cost for everything. Then after that, the architects and also all the other consultants will be on board. So during the design stage, the BIM model will develop to the LOD 300. So after the final up the design and everything, so the LOD 300 will be developed to the LOD 400 during the construction. So incorporate all the detailing and also the information. Then from the LOD 400 will be developed to the LOD 400, which means the S-bid during the operation and the maintenance. Okay. All right. So basically, BIM model as a data container. So if we look specifically at the Revit BIM model, it contains various types of data. So what the data that can be have in the BIM model? So number one is about the documents, about the geometry information, about the equipment, the system class, the 3D libraries, what we call it as the Revit family, and also the maintenance record. So all this information can, it's not necessary to fit in one time, but basically will be developed starting from the design stage, construction stage, and also the operation and maintenance. So by end of the product for the SP in the LOD 400, you can see that the richness of the information that will be fit in the BIM model, it can be what we call it, all this data can be exported and then processed by the ArcGIS platform for analysis and variety of other applications. So that's why from this information will be exported and go to the GIS ArcGIS platform. Okay. All right. So for the next one, I would like to do the what we call it the case study from the one of our project that we have collaborated with the ArcGIS platform. So it's called the Pago Education Hub at Johor. So this building divide into the several building. So they have the UTM, IIUM, UTHM, and Polytechnic. So all these building also have been connected with the shared facilities. Okay, this building, this project will be owned by the Samdabi and then have been executed, designed and built by Tunas Selatan Construction. Okay. And then basically for this project, the Pagoda Keshara is about the LOD 400, so as built. So when we onboard, we need to create the LOD 400 based on the as-built drawing that we provided by the Tunas Selatan Construction. Okay. All right. Okay. So here is the what we call it the sample of the one of the building and also the ancillary building is consists of the architectural, structural, and also the MEP BIM model. So this one, as you can see, one a sample of the SAMV system. So when I click to the one of the item, okay, so we appear what we call it the properties or the information that already incorporate inside there. So basically from this information, you can know about the width, about the size of the item, the equipment, and then you can know about their models. So what is the model of the item, who is the manufacturer, and also you can put the cost, so how much that this item is costing, and then also you can add also the capacity of the item or the equipment to incorporate in the BIM model. Okay. All right. So beside this one also, we also like this one, the other sample is about the cold water system. So from the big item, for the water tank and also the pump, we also model it as per as-built drawing we receive. So like you see one of the sample of the pump that we already model. So basically we put also what we call it the article number. The article number, which means the pump serial number, the manufacturer, the description, and then about the warranty, the Omni class, the cost, and also the pump capacity. Also we incorporate in the BIM model. So this information is helping during the operation and the maintenance stage. So when the maintenance team would like to identify what is the problem with the item or the equipment, so they can refer to this BIM model. So beside all the big item that we model, we also model to the small item, which means including the pipe, fittings. So this one of the cold water fitting is a valve. So when I click to the valve, as you can see that, so all the information about what the valve is there. So the information of the valve, so for example, like the material, the capacity, and then what we call it, the flow, the cost, and also the sizing. That's more important also when we incorporate in this BIM model. Okay, so they also careful with the manufacturer and also about the what we call it, the warranty document also can be incorporated. So as I mentioned that basically the 3D BIM model, there's no restriction to incorporate the information. Okay, this information is helping and is useful when when we collaborate with the ArcGIS platform. Okay, so basically the ArcGIS platform integrate with the BIM model is helping that for the new player at this area to what we call it identify what is the potential thing that they can develop around this Pago Education Hub, which mean that they just assess the ArcGIS platform, which already incorporate our BIM models. So from there, they can do the analysis and also the other application that is helping for their future development in this area. So basically, for the next one, for the collaboration with the Revit BIM model, with the ArcGIS platform. We let my colleague, Ms. Hidayah, to continue about it. Thank you.
Thank you, Mr. Hafiz, for the overview on the Revit model. Now, the video is showing how Revit model is integrated in ArcGIS Pro. ArcGIS Pro has the ability to read and use Revit models directly in 3D scene. So you can use these following steps to position your data using georeference tool in ArcGIS Pro. However, there's no guarantee that the information in the Revit model has been altered to respect any non-coordinate system, because Revit models are never drawn with the units of latitude and longitude. Therefore, before you start, you may need to ask the author of the Revit model where the model is supposed to be located. Knowledge of a street may be enough. It's also important that you have a good idea of what coordinate system should have been used for that geographic area, so that we can define the projection easily in ArcGIS. So these GIS tools will help to understand how to put the infrastructure in the context of surrounding or topography details. Meanwhile, BIM information is the vital element that allows for the designing and building process of that infrastructure to take place. So this is the process of blending the BIM model into layers of geospatial context. So BIM designers can use the GIS to get the most accurate information about some areas where construction is to take place. If the area is prone to flooding or landslide or other environmental impacts, BIM designers will learn about it and influence a structure's construction materials, orientation, and so on. So this video is showing one of the spatial analysis that we can have for the development, which is to know the road reserve around the BIM model. ArcGIS Pro also can drill down to the details and information of the Revit model. So it just can display easily by clicking on the model structure, and we can navigate around the model from outside to inside of the building. With the supporting of either 2D and 3D spatial data, it will be necessary for planning all operations regarding any development infrastructure. Okay, so this is another value-added analysis that you can have in ArcGIS Pro to support the surrounding information of certain development. It can provide you the demographic and population information to help in planning a good development and to support the operation policy. I hope you understand how the BIM GIS integration flows work. I will pass to Caleb to explain more details on common BIM GIS workflow. Thank you.
So thank you, Mr. Hafiz and Ms. Hidayah, for the insights into projects currently delivered by steadworks, as well as some of BIM's capabilities. I would like to share with you some of the common BIM GIS workflows and understand the underlying components. Now, this is just an illustration of how you can begin to implement. You don't have to follow this, but it's an example of how you can leverage your existing enterprise system or ArcGIS online environment, as well as your Autodesk subscriptions to construction design products such as Revit or Civil 3D. Beginning from the design stage, as the Revit files can be read directly by ArcGIS Pro or transformed through automated workflows into useful GIS layers to be visualized and analyzed with the project's surrounding environment. Essentially creating an environment within your organization that is capable of not only managing one single project, but can be reused for multiple projects, all the way from project planning to operations and maintenance and all over again. You can implement such solutions on-premise or using your existing organization's cloud. And in summary, what you can see here is what we have currently in terms of GIS and BIM integration. The ability to integrate data, publish on ArcGIS Online Enterprise into InfraWorks and Civil 3D, and also access your BIM and CAD files that are stored on the Autodesk Construction Cloud from within your ArcGIS Pro. With the release of ArcGIS GeoBIM, it will feature a tighter integration, which in the Autodesk Construction Cloud and ArcGIS Online Enterprise, it will enable the creation of a GeoBIM project and GeoBIM applications. Now, linkages between features in the ArcGIS and the files stored in the Construction Cloud can be made. And both sets of data can be visualized within the same application, supporting integrated visualization and querying. And to illustrate this video shows on the left what you would see in the GIS. There is a base map infrastructure layers, and the building scene layers. And what is selected is in the GIS is the AC unit on the rooftop. And on the right-hand side is the Autodesk Revit model of the selected AC unit. And there you will be able to examine the full route of the ductwork and the engineering specifications that are linked to this AC unit. And now the same can be done with Autodesk Civil 3D models and AutoCAD files. When a rail feature here is selected, I can open up the link and see the latest work in the progress infrastructure drawing that is shared by contractors on the Autodesk Construction Cloud. And this ability to bring GIS and BIM together in this manner helps to improve coordination across the full project team. Now on to more detailed use cases that we foresee to be the future of the highway and railway industry. Each of these come with the underlying challenges that the users face, the solutions that they have come up with, and the benefits that they have reaped throughout the process of realizing the solutions that were once only theoretical. So I would like to bring you to attention for HS2, which is high-speed rail 2. This is based in central London, and it's about combining 3D GIS and BIM to improve collaborative working. So, well, you can understand that building in a very densely populated environment such as central London is going to be a challenge, as well as the historical significance of the structures there. And the other challenge that they faced was to aggregate design drawings as well as calculations into one single platform. So the solution that I came up with is to, using ArcGIS Enterprise, to build and enable multiple teams to create new applications for their own departments or own teams. And on top of that, being able to automate data conversion between GIS, BIM, and CAD files. The benefits that they've reaped is that they've been able to address the analysis and data sharing needs between departments, between councils, between consultants, and as well as to provide evidence to display the context on site, to have an authoritative data set that once you're on site, you'll be able to share with everyone. So really, this is an integrated 3D and GIS BIM environment. And this really combines the strengths and eliminates any weaknesses in collaboration between teams. Now, the next user case study is this automation of GIS and BIM workflows in the existing GIS portal. So the challenge that Jacobs Engineering Consultancy faced for Highways England is that they have restricted understanding of CAD to many of the personnel within the project itself, because CAD files are understandably detailed design and detailed drawings, and they are not necessarily understandable to laymen. And this has also limited visualization and analysis of the projects. Now, the solution that I've come up with is to automate the CAD processing workflows in GIS using model builders, as well as leveraging the ArcGIS portal to tap into the national grid to enhance and enrich their existing data set. And the benefits that we've reaped is also to be able to impose new designs against existing data sets, as you can see in the illustration below. So you can see that there's this flyover, crossovers, and also this alignment directly next to the existing highway. And this has been good to visualize in 3D. And on top of that, the project personnel are also able to apply changes to multiple files or projects at the same time. And these changes really have allowed Jacobs to save considerable time and money for Highways England. And the third user case study I would like to bring your attention to is bringing underground utilities to life with mixed reality. And really, this technology leap brings all of us closer to realizing an age-old wish, which is to be able to see through dirt, right? So this is a use case near New York. So the challenge is that they've been facing that they need improved job safety and also to avoid damage to utilities, both of which can be very costly to repair. And these errors of marking line on asphalt and concrete has also been a bother because the engineers in the office can't actually visualize or be able to monitor what's going on site. So the solution that Esri has came up with Microsoft's Azure and HoloLens is that on top of being able to visualize the underground utilities using a virtual reality machine, they've also been able to establish a remote connection with the engineers in the office in real time. So the engineers in the office are able to view the perspective of the field worker and immediately provide comments based on the context of the environment as well as the utilities. And the benefits that they've been able to reap is that they've been able to avoid redundancies, repeats in utility jobs, having to do repeat visits just on one site. For example, I forgot to mark this utility up. I forgot the field worker did not close the cap, or just simple things like this, having to repeat jobs. And to be able to close service tickets quickly and safely. So coming to that transportation use cases, how do we embrace digital transformation? And how do we leverage the science of where? How do we take the next step forward? It's quite simple. We just need to take the initiative. All right. We need to continuously embrace the technological advances as fast as they are coming, to be able to learn continuously, take action within the organization, to inform and educate our colleagues, our friends, our peers, and to understand the possibilities of working together and how much time and money we can save by seamlessly collaborating through ArcGIS and BIM. So thank you. Over to you, Nasmin. Thank you.
Okay, great. Thanks, Caleb, Mr. Hafiz, and Ms. Hidayah. There was an eye-opening presentation on the GeoBIM, and also I hope that the audience can get a better insight in terms of the integration between the GIS as well as BIM. Actually, so we have had a couple of questions coming through. If you have been listening intently to Mr. Caleb, Mr. Hafiz, and Ms. Hidayah, and you haven't had a chance to type out your question, there's still time. So you can do that in the question pane. So to just kick off, we have one question who asked actually from Miss Ying. She's asking that what are the Autodesk components that are integrated with GIS GeoBIM specifically? I think this is a question for you, Caleb. Over to you.
Thank you, Nasmin, and thank you, Miss Ying. What are the Autodesk components that are integrated with ArcGIS GeoBIM specifically, right? So Autodesk BIM Collaborate, first of all, will be used to connect decision makers and construction teams to manage design review, right? You can easily track the designs, coordination, quality, safety, and all this by linking data from Autodesk BIM Collaborate with ArcGIS GeoBIM. And the second one is Autodesk Docs, which is a cloud-based document management and a common data environment for project information in the Autodesk Construction Cloud platform. Back to you, Nasmin.
Okay, great. I hope that's answering your question, Ms. Ying. And for the second questions, actually coming from Mr. Hamza. Okay, he asking that, it is a great question. When will you release a GIS GeoBIM? Over to you, Caleb.
Thank you, Mr. Nasmin. So ArcGIS GeoBIM will be released for ArcGIS Online only end of this month. And afterwards, Esri will also formally launch the product in October at the Autodesk University, as well as the IMGIS conference they will be introducing Artis GeoBIM to some of the AEC firms and also the owners and operators. Yes, over to you, Nazmin.
Okay, great. I hope that answering your question, Hamzah. And we continue with the question number 3, which is coming from Miss Liana. She asking that will ArcGIS GeoBIM be available within enterprise solutions? I think it is for you, Caleb.
Thank you, Mr. Azmin and also Elena. So ArcGIS GeoBIM will release for ArcGIS Enterprise in 2022. So in the meantime, you can try out ArcGIS GeoBIM, which is in ArcGIS Online. If you are keen to try it out, you can do it with the early adopters if you are current on your maintenance of our ArcGIS products. Thank you. And back to you, Nazmin.
Okay, thanks, Caleb. I hope that answering your question, Miss Liana. Okay, let's continue to the next questions, which is coming from Mr. Izzuddin. Okay, he asking that, is it possible to view a BIM model using ArcGIS web without using ArcGIS desktop, which is ArcGIS Pro? I think it is related to presentation from Mr. Hafiz and Ms. Liana. I think one of you can answer this question.
Yeah, yes, it is possible. But at this current point in time, there are no workflow to import Revit models directly into online or enterprise. It still requires ArcGIS Pro to read and locate the Revit model. Then only we can convert the BIM layer to geo database in order to publish the model in ArcGIS Online. So as a result, we can have the BIM model in ArcGIS Online seen and to share with others or to non-technical audience maybe, which may also require to interact with the BIM model. But they do not have the CAD or BIM or GIS skill software to do so. So they can just view from the published scene in ArcGIS Online. Yeah. Over to you, Nazmin. Yeah.
Okay, thanks, Ms. Hidayah. I hope that answering your question, Mr. Izzuddin. I believe this is the last question that we have coming from Mr. Chow. He asking that how this BIM GIS integration can help in structures of the life cycle. I think it is also related to presentation Mr. Hafiz and Ms. Liana. Okay, over to you guys.
It can help, yeah, it can help in risk assessment phase, placing a digital design in real place within real geography. So it eliminates much of the front end risk of designing and building. So usually the biggest delays in large infrastructure projects come from the planning and permitting phases, which involve a lot of assessment of maybe social economic, environmental impacts, and so on. So engineers and planners do much of their assessment outside of the design process using geospatial data. It's how they look at the flood maps or locate underground utilities. So why not we just design using GIS and BIM data simultaneously? So it really can help in risk assessment.
Okay, yep. Great. Thanks, Ms. Hidayah. I believe that's answering Mr. Chow's questions. I think that's all the time we have for today. If we have not answered your question, we will surely reach out to you with the response later. We really love your feedback, so take time to fill out the brief survey that you will see in the pop-up at the end of the session. Further feedback or question can be sent directly to our email, which is events@azulmeasure.com.my. And finally, if you would like to rewatch this webinar or share with your colleague for the recording, will be shortly available on the Azul Measure event page. Again, thanks to you, Caleb, Mr. Hafiz, and Ms. Hidayah, and thanks everyone for joining us. And we will see you for the next Direction live online webinar. Before I end it, if you have any inquiries incorporating regarding for today's session, which is the GIS and BIM into your organization workflows, do contact us from our representative from Israel Malaysia, which is Ms. Jai, and also representative from Steadworks, which is Ms. Hidayah. I think that's all for today. Stay safe, everyone. Bye.